I find that's better there because I can then look at the camera. I look at the screen, see me, and I look at the camera. That's better. Right.
1 minute.
Bother. You get this other drink. I went upstairs.
What? I can grab it. I can do it.
God's teeth. Of course, if the lid is buggered, then it won't come off and go on. Hello and welcome to another maths topic by topic. One of the hardest topics that students find is doing that of ratio and proportion. And although it's not really that difficult in my opinion, the students seem to find it always quite a challenge, and if you ask which are the most difficult problems to try and solve, they usually come up with, oh, it's ratios. I hate ratios. So let's get stuck in and have a look at some simple ratios and how to solve them. We might be given perhaps something like this, and you want to write a ratio and you're given one, perhaps let's say, and it's going to be 5 to 15, and you want it in the simplest version, which is 1 to n. How do we go about these? Very simply, we take the smallest number and divide it into the largest number. So we think of it like this, and 5s into 5 go 1, and 5s into 15 go 3, and there is our simplest ratio. Many times we're asked to express things like 1 to something else. Let's have a look at another one. I've got perhaps 8 to 32. So simply, again, we divide by the smallest number. And 8 into 8 go 1, and 8 into 32 go 4. So it gives us a ratio. What does cause some problems is if I'm asked to express this as a fraction. And what I get from a lot of people is they look at this and they say, well, yeah, that's a quarter and that's 1. No, that doesn't make any sense. And what we have to do is we need to add the two together. So our 1 plus 4 is going to equal 5, which is going to be our fraction, and then I've got 1/5 to 4/5, and that gives me a way of trying to represent what we've got. Let's have a look at a longer type of problem. So perhaps in a school there are, I know, let's say 120 computers, and there are, let's say, 600 students in the school, and what we want to do is we want to work out what is the ratio of computers to students. So 120 to 600. Let's simplify this, and I'm not very good at dividing by 120, so let's divide both sides by 10, and now I've got 12 to 60. let's divide both sides by 12. 12s into 12 goes 1, and 12s into 60 go 5. So here we've got a 1 to 5 ratio of computers to students. Now, sometimes when we're trying to do these things, we're working out, if you like, equivalent ratios. Let's suppose one of the common problems is I'm going to make some concrete. We'll do a very simple example here, and I want 2 parts cement, and that's going to go to 5 parts sand. And we can turn these to any particular numbers we want. So let's suppose I use 4 of cement. How much sand am I going to require? So let's work out what we've got. We've got 2 to 5. But this one here is going to be 4. Now what have I done to the 2 to get 4? We've multiplied it by 2. So we multiply the other side by 2. We do the same to both sides. And therefore I'm going to need 10 parts of sand. So we're simply multiplying these out to get some sort of simple ratio again. And if I had perhaps, oh no, let's say 20 buckets of sand, how much? Well, we look at what we've got. What have I done to this 5 to get 20? Well, I have multiplied by 4. So to get from my 20 down to my 5, I would actually divide by 4. So if we want to work out what this is, so I've multiplied my 5 by 4 to get 20. I'll multiply my 2 by 4 to get 8. So in this case we'd need 8 parts cement. And this is sort of quite a common type of sort of problem that you get to try and work out how things work. Let's try sharing something on a given ratio. And this is a very common type of problem that we get where we might have some money inherited. So let's suppose we have rather an easy one to start with. Let's have something like £90, and I'm going to share £90 with 2 children here, and I'm going to have with Abby and Bill. They're the shorter names I can think of. Right, and they're going to be shared in the ratio perhaps of 4 to 5. It's a very simple example. Usually they've got harder numbers, but I'm not trying to make the numbers difficult here. We're looking at how to get it to work. £90 shared in the ratio of 4 to 5. So what we do is we add the 4 and the 5 together to give us 9. We then take our £90, we divide it by 9 to find out what 1 share is. And having got 1 share equals £10, then Abby here will get 4 times £10, and Bill will get 5 times £10, which is 50. So sharing in a particular ratio is not really very difficult. If we've got more people, so let's have Ali, let's have Ben, and let's have Carl, and each of those are going to share, let's suppose we have £42, and they're going to share them in the ratio of 1 to 2 to 3. Let's add these up. So that's going to give us 6 shares. To find out what 1 share is, it's going to be the 42 divided by the 6, which gives us 7. So I can say that Ali is going to get 1 share, and that's going to equal £7 in this case. Ben is going to get 2 shares, and that's going to be 2 times 7, and Carl will get 3 shares, which is going to be 3 times 7, 21. Where do students go wrong? Too much writing here. Too much writing, Philip. I can't be expected to write that much. Yes, you can, because this explains what's going on. And quite often, these are names like A, B, and C, and you could, if you wanted to, just say here something a little bit similar or simpler. I could say A is going to equal 1 times 7, which gives me £7. B could give me 2 times 7, which is £14, and so on. So I can make these a little bit easier if I want to. Another example of this, let's suppose Fred, my favourite character, and Fred buys a box of fruit. And inside there are perhaps apples, oranges, and let's have some bananas. And these ratio are going to be in the ratio of, I know, 5 to 3 to 1. Now, let's give ourselves a problem. And we're going to say that the total number of fruit here is greater than 50. So we know there are a minimum of 50 items of fruit. So I want to know what is the minimum number of oranges. Five to 3 to 1. Let's add them up. 5 and 3, 8, and 1 is 9. So we've got 9 items. So we've got 50 divided by 9. And of course, that's not going to go. So what's going to be the largest number, well, the smallest number above 50 that 9's going to go into? Well, I know that 6 9s here are 54, so that could be my minimum number. And if then 6 is 1 share, then if we put that together, I want 3 shares, which means it's going to be 6 times 3, which is going to give me 18 oranges. So that gives me a way of trying to work out how I could do some simple percentages here. Many of these, when we do these percentages, are basically in direct proportion. And let's have a look at how some of those go. So let's suppose we've got something fairly easy that we say that, I don't know, 5 rolls cost £2.50. How much do 9 rolls cost? In this case, we work out the cost of 1. So the cost of 1 roll here is going to be £2.50 divided by 5, which gives me 50p. I now know the cost of 1. 9 will cost 9 times 50p, or I could write that as 0.5. Let's multiply this up. This is going to give me £4.50. So this is direct proportion of working out what 1 is, and then we can work out what several are. Let's look at a simple one of these. We've got then a car, and a car simply here travels at 50 miles per hour. Okay, so perhaps we want to work out here the time to travel 150 miles. I haven't tried to make this one very difficult. So if we travel 50 miles in 1 hour, the time to travel 150 is going to be 150 divided by my 50, and that's going to give me 3 hours. One of the favourite sorts of questions that we get is that of recipes. I always like some of the recipes because you can learn a lot about different sorts of foods, and you might find that generally they're usually real things, and you can learn all about different foods. So let's suppose I want to make some soup, and for my soup I'm going to want 200 grams of carrots, we want 2 onions, we want 80 grams of butter, and we want 300 milliliters of water. And that is soup for 4 people. So we're going to get usually some horrible number, but let's do an easy one. So if I want it for 2 people, then we're simply going to require half the amount. 100 grams of carrots, 1 onion, 40 grams of butter, and the 300 will become, I started writing before I was ready to write it, is 150 mils of water. Let's suppose we're asked for 10 people. Then a way of working out for 10 people would be, I would take the 4 and look at how I can make 10 from that, and if I divide it by 2, find half the amount and then multiply it by 10 up, so that's going to now have to multiply by, to get the 10 I'd have to multiply the 2 by 5, then we can work it out. You could have worked it out for 1 person, but I've already done the 2, so I don't need to work out the 1 because I only need to multiply these by 5. So 500 grams, 5 onions, 200 grams of butter, and 5 times 150, which is 750 mils of water. Often these problems aren't just recipes, but they like to do some other types of problem. Amazes me how things get in my way. There we go. Let's do some currency conversion. Because this is done in exactly the same way. So let's have an exchange rate. And we'll say that £1 equals, I have no idea what pounds to euros are at the moment, let's say it's going to be 118. I have no idea. So if we think about it, if I have got pounds, then I'm going to get more euros. My pounds, I'll get more euros. £1 would give me £1, 118 euros. So let's suppose we've got £200. How many euros is that going to be? Well, easy enough to do. We're just going to multiply this number here by 200. Now if you need to, you could use a calculator, and let's do that. So we've got here my 1.18, and I'm going to multiply that by 200. And that's going to give me the answer of 236 euros. Now, when we've done that, we might have another problem of trying to work out what it's going to be when it comes back. And the conversion rate would be probably worse here because the exchange rate's going to change as markets fluctuate. So let's suppose on the way back we're going to have this set to something else. Let's say we're going to have this set to £1.12, let's say. The pound is worth less euros. So last time the pounds were going to give us more euros. This time we've got lots of euros and we're expecting a smaller number. When we expected a larger number, we multiplied. When we're going to expect a smaller number, we're going to divide. So let's suppose I bring back 25 euros and we want to work out how many pounds is that. We're this time going to divide by 1.12. So let's go to the calculator, and this is simply going to put our sum in 25 divided by 1.12, and that's going to give me a horrible number. I've got 22.3214. Let's work that out. So I've got to round to the nearest penny, so this is going to give me £22.32. So we've converted from here currency moving one way and moving the other. Direct proportion is quite an interesting one to try and do, and there are simple problems with this and more complicated ones. Let's start off with looking at something that's really quite simple. So if I want to look at a simple problem here, we've been doing some proportion, but we might have an equation that says something like A is proportional to B, and I can rewrite that as A equals some constant, and I'm going to call it K, times B. Let's suppose we've got some sort of simple relationship here. Let's say that A equals 12 when here, let's suppose we've got B equals 6. So I now know that 12 equals some constant times B, which here is 6. Rearrange this, we've got 12 divided by 6 equals my constant, so my constant here is going to equal 2. Let's rewrite that equation, so I now know that A equals 2B. And then we might be asked to work out what is A when B equals 5. We can then substitute in here that A is going to equal 2 times 5, so A will equal 10. This is direct proportion. But we can also meet this as inverse proportion. let's look at inverse proportion. A is inversely proportional to, so we write 1 over B. So I can write that a different way, getting rid of this proportional sign to say that A equals K divided by B. Then we have exactly the same problem as we had before. So let's suppose here A equals 12 when B equals 6. I'll use the same numbers, but it's going to give us a very different type of result, because now I know that 12 equals K divided by 6. So we rearrange this formula. So 12 times 6 equals K. I've multiplied each side by 6, and those 6 cancelled. So here K is going to equal 72. Then we can work out another one, which is going to say, it can be either way, I suppose. What is A when B equals 3? To work out this, we've got my equation, which I didn't write out, which was A equals 72 divided by B, and we can work out what we've got here. A equals 72 divided by 3, and for those of you who aren't very good at trying to calculate that, then we could do 72 divided by 3 gives me 24. Which gives me indirect proportion, or inverse proportion. This causes, I know, a lot of problems for students, and this one is a typical type of problem that we would get. So we might get something like this. If it takes perhaps 10 men 2 days to cut a hedge, then how long would it take if there were 5 men? And this causes an awful lot of problems, because I often get from this that it's actually going to take a shorter amount of time. At 5 men, it's going to be shorter, isn't it? No, it's going to take longer. So we've got half the amount of men, therefore it's going to take twice the amount of time. So it's going to take here 4 days. How about if it was going to take 4 men to do it? How would we work out this? With 5 men, it was fairly obvious, but with 4 men, it's going to be more difficult. So, if it takes 10 men 2 days to cut a hedge, how long would it take 1 man to do this? Well, that's going to be 10 times 2, which is 20 days. if I've got 4 men, then we're going to have this number, and we're going to divide this by 4. And there we've got our answer. It's not done perhaps in quite the same way as you expect, because some of these really aren't very nice trying to work out some of these problems. All these ratio problems come in sort of all sorts of nasty things. One of the ones you get are maps and scales, because you're given some horrible numbers to work with. Like a map here might be set at 1 to 50,000. Now, what does that mean? It means simply, perhaps, for example, that 1 centimetre on the map would be equivalent to 50,000 centimetres on the ground. Ugh, I can't work out that. So centimetres into metres would be 500 metres. So 1 centimetre equals here 0.5 kilometres on the ground. Once I've got this, we can work them out usually a little bit more easily, because these ratios and proportions become sort of easier to work out. Some of these proportions aren't particularly nice. They give you all sorts of problems to try and cope with, because, well, they can, I suppose. That's the real reason. So we get this idea of direct and inverse and direct proportion to try and work out some of those bits and pieces. Right, let's see if we can look at some other ones where we've got one of these problems to try and do. Looking at inverse proportion, one of the favourite ones that I know is that the frequency of sound is inversely proportional to the wavelength. There we are. So let's see if I can write that out. So frequency is inversely proportional to the wavelength. And I've got these horrible symbols just to make life nasty, because that's the way that it is. And let's suppose that middle C is 256 Hertz, and that's got a wavelength of 1.29 meters, and we're asked to work out what perhaps 440 Hertz might be. Let's use the formula to try and help us. Frequency here equals K over lambda. Don't let the symbols put you off. So my frequency here, 256, equals my constant over my wavelength. K is going to be 256 times 1.29. That's going to give me K. Well, for that one I'm certainly going to have to use the calculator. So 256 times 1.29. And that's going to give me an answer of 330.24. Oh, let's round that. No, we're not. We're going to leave it as it is because we want to get as much accuracy as we can, and we only round right at the end. Let's write my formula out then. So my frequency equals 330.24 divided by lambda. Now we're asked to work out what it is for 440 Hertz, what the wavelength is. So I've got here 440 Hertz equals 330.24 divided by lambda. We'll rearrange this, and so we'll multiply both sides by lambda. They'll cancel out. Divide both sides by 440. So my sum is going to be lambda equals 330.24 divided by 440. And let's do that on the calculator. I've got my 330, so that's my answer, divided by 440. Third decimal, and that tells me that my wavelength for this is going to be 0.75054. And let's do this to 2 decimal places. So that's going to give me 0.75 meters. I hope that's given you some idea about ratios and proportions. They're not quite as difficult as they seem. A steady head helps. Break it down into simple things. Try and work out what 1 might be. And that's the easiest way of trying to do it. So I've tried to take at least one of each different type so that you've got an idea of how they work. Take care, stay safe. If you found this useful, then please subscribe, and I'll see you next time for more maths topic by topic. Take care, bye bye.